Okay, so hi everyone, Senan this side. Today we are going to solve this spiral matrix 4, right? So it's a classic problem. If you've seen spiral matrix 1, 2 and 3, I think I've made a video on spiral matrix 3, but the idea that is used here is exactly same as spiral matrix 1. Nothing different. In that you just collected your input in a list, and this you're just placing the values in the grid, right? And so the thing is, it's also a linked list problem, which means you have to place the values of elements in the matrix in a spiral order, and this order is given in your linked list. And the question is pretty straightforward, very simple. I'll try to be as direct as possible because it should not take much time to explain, right? Okay, so let's look at one of the test cases, because you can read this and this is your linked list, and for some reason you're not able to fit all the elements in the matrix. So what you do is you fill the remaining one minus 1. Fine. So m is 3, n is 5, so 3 rows and 5 columns, and the linked list is this 3026, 3026, 817, 817, 942, 550, 942, 550, and the remaining is minus 1, minus 1. So you see we are going in a clockwise fashion. Similarly, in this case as well, we are going in a clockwise fashion, but the thing is there is only a single row, so you don't see turning. So linked list has 0, 1, 2, you see 0, 1, 2, and the final number is minus 1. So I'll try to be as brief as possible in the dry run, because if you have solved spiral matrix 1 and 2, it's a piece of cake. And if not, you can just go and check out the videos that I've made. I hope that I've done the dry run on a notebook. Okay, so here we are in my notebook, and this is where I would be discussing the idea of how to solve this problem, right? You're given the number of columns, right? You're also given the number of rows. So m and n is already given to you. Now what I would do is basically I will initialize a 4, not a 4, but I'll initialize 4 pointers. So this is basically a 4 pointer approach of traversing this matrix. So for this, I'll say this is the leftmost column, and this is the rightmost column. Similarly, this is the topmost row, and this is the bottommost row. So what is the value of top, bottom, left and right? What are the values for this? You see, this is pointing to the 0th row, and left is pointing to the 0th column. So clearly top is 0, left is 0. Now what about the bottom? Bottom is the last row, which is n, but it's 0 based indexing, so n minus 1. So bottom is n minus 1, and similarly right is m minus 1. And this is how you determine the initial values of your matrix, this spiral order. So what I'll do is I'll just explain you, and then we'll see the code. In this, first I'll pick up the topmost row and fill all the elements from left to right. I'll fill this using a for loop. Then what I'll do is I'll take this and I'll shift this pointer one step down. Now I'll take the rightmost column, and when I take that, I'll fill in the elements from top to bottom. I'll fill this and I'll fill this, and after I'm done with this, I'll take this right and I'll shift this one step to the left. Now what I'll do is I'll go to the bottom row and I'll fill all the elements from right to left. So I'll fill this, I'll fill this, I'll fill this, and after I'm done with this, what I'll do is I'll take this bottom pointer and I'll shift it one step up. Now since I'm done with that, what I'll do is I'll take the leftmost column and I'll print from bottom to top. Since we only have a single element, I'm done with this. And when I'm done with this, what I'll do is I'll take this left pointer, shift it one step to the right. Now what I'll do is I'll take the topmost pointer, and I'll see which is the topmost row currently, which is not filled yet, and I'll fill all the elements from left to right. So if you observe, we've already traversed this matrix once. Now we are going for the second loop. What I'll do is I'll fill this and fill this, and with this this is done, I'll update top to one step. Now if you see, top has crossed the bottom, right? Bottom should have a value that is greater than the top, which is now not true. So that means we have filled the matrix. Other way could be, you could just check if left less than equal to right, left is greater than right, then you break out either of the case. This is true or this is true, both would work, right? Now in the while loop, I have put the condition for this and this as well, but even if you use this itself only and or this itself, this would still work. Now let's look at the code. How do we actually implement this? It's quite straightforward, and there's a corner case, or the way that you have to understand this. and I'll show that in the code. Okay, so here we are back in my IDE of LeetCode. So what I do, first of all, you need a matrix that you have to return, right? So vector of vector int spiral m rows and n columns. So I initialize this. Another way could be to just add a -1, because if you're breaking at the condition, if linked list is number of elements in the linked list is less than the elements in the matrix, you could just initialize them to -1 and you don't have to worry about placing the values -1. But I won't be doing that. And since we have a node, we need to have a pointer that would point to the head, which will allow us for the traversal in the linked list. Now, as I said, top, bottom, left, right, these are the 4 pointers that we are going to initialize, and now we are going to actually see the traversal in while loop. You see, top is less than equal to bottom and left is less than equal to right. I assume if you remove this as well, still work. Just for the explanation, I'm just showing you both of them. So either you remove this or remove this, this would still give you the correct solution. Now what I said, I chose the topmost row, and then I fill all the elements in the topmost row. So I'll take this top, and my j goes from left to right, and j plus. So spiral of topmost rows, jth column, I'll say if temp is not null, place the value of temp value in that node, otherwise store -1. And if temp is not null, you update this temp to the next element, right? Because you are traversing the linked list as well while you're traversing the matrix. So this way I would be able to fill the topmost row, and when I'm done with that, I'll just update this top value to top plus plus. So I'm increasing the top value. At the same time, now what I do is I'll fill the rightmost column, right? So from I goes from top to less than equal to bottom. What I'll do is I right, so ith row and rightmost column, you again check if temp is null. If temp is null, you return -1. If temp is not null, you place the value whatever is stored in that temp's val, or the data stored in this node. And again, if temp is not null, you update this to the next node because you used that node, right? Fine. And this is what I do is right minus minus. Now you see this if statement and this if statement again, right? Now we'll discuss why that's there in a moment, but you see the inner thing. So this for loop is similar to this, but in this case you're traversing the bottommost row and filling from right to left. Similarly, in this for loop, you're filling from leftmost column from bottom to top, and in that case you increment the left pointer, left plus plus, bottom minus minus. Anyway, now why is this if statement, right? This if statement is because you see, let's say this condition is violated. So when you go into this for loop, temp is less than equal to bottom, left is less than equal to right. So you'll go through this for loop at least once. You'll go also through this for loop at least once because the condition is like that. What would happen is if temp is less than equal to bottom, that means we are at a valid top. Or why do I check this? Because when I enter this while loop, I know this condition is true, top is less than equal to bottom, but I am still updating this top value, right? Since I'm updating this top value, what could happen is this bottom could have a value less than top because I'm updating this top, right? So for the case where top is equal to bottom, when I do top plus plus, bottom's value is less than what is the top's value. So that means we have seen the matrix, right? So we don't want to actually update the bottommost row again. So if you don't check this, there's a possibility that you'll rewrite a particular row of your matrix. So we don't want that. We only go through this for loop when bottom is a valid location, right? Bottom is a location that we have not filled yet. Similarly, after that I'll just do bottom minus minus. Now what I'll do is I'll see this left is less than equal to right. Let's say this is not violated, this is violated. So again, the same condition lies here as well, and that's the idea. If left crosses right, so you would be filling a column which is already filled and which does not need to be updated. So that is why this if statement is there. But I've not put a lot of mental effort to writing this code because this is exactly same as what you'll do in Spiral Matrix 1 as well. So since the idea is same, the only thing you have to worry about is how do you traverse the linked list at the same time. And this is what I've done. This is my method of iterating through the linked list. So yep, that was the whole video all about. Obviously I'll show you the test cases are working fine. The solution is also accepted. And now we'll see the time and space complexity of this solution. Clearly, for returning the solution, you have to create an m cross n matrix. So clearly at this point itself, your space complexity is m times n. And what is the time complexity? You're breaking the while loop when you're traversing all the elements in the matrix, right? So for traversal, you have m times n elements in this matrix, right? So this time complexity is again m times n, although you see a while loop, multiple for loops inside this while loop. But what this actually does is just traversing this whole matrix once in a spiral fashion, but it is traversing exactly once. So that value is m times n. So this total while loop, including the for loop, will be traversing this matrix m times with time complexity m times n, and in the end you return this spiral. Okay, so a couple of things you should know, since this we are using STL, right? So STL is by copying, it is passed by value. Whatever value you are placing it here is passing by value. So there's a overhead of copying all the elements, right? So you see you are returning, this return type is pass by value. So when you create the spiral matrix, the existence of the spiral matrix is only inside this function, right? So after this return statement, that object of vector int does not exist, but you are returning this. So what this return would do is call the copy constructor of this vector int. So what you'll be returning is you'll be copying this whole matrix you created and you'll return that. So this is, so you won't see this, but a copy constructor is called a vector int. So there's an overhead of copying, right? So in a nutshell, you will be using n times n space inside the function. You'll be having an n times n space that is being returned. That's not exactly the same as spiral. So, and also there's a overhead of copying all the elements. So first we are traversing all the elements in this matrix m times n, plus the copy constructor, if you consider that as well, that also takes m times n. So 2 times m times n is the time complexity, which is m times n in. So yeah, that was the whole video. Hope I was explained this to you. It was quite straightforward. I'm not going into that much detail or touching the corner cases because it's already covered in spiral matrix 1 and 2 and I think 3 as well. Not exactly. 3 is a totally different question, but yep. Yep, that was the whole video, and thanks for watching. I'll see you in the next one.